Hi everyone. Let's start a new topic which is linked list, and this time we will be using Python. In this particular lecture we will first understand what is linked list and how to implement this linked list in Python. I hope you have already watched the previous lecture that what is a class and objects in Python, right? So that lecture is also available on YouTube. So if you do the YouTube, then you will be able to see that lecture. Let me just show you. This is the lecture I was talking about. Basically, this lecture has everything which is required to understand the objects and classes in Python. I just uploaded this lecture like few hours ago. Okay, just watch this lecture, and once you watch this lecture, then you can watch this particular lecture, right? This is kind of I'm saying this is a previous lecture that you should be watching before watching this video. So this is the previous lecture because then only you will be able to understand what are the classes, what are the objects in Python, right? And then you can continue with this lecture. Okay, so let's get started. Now, let's first understand that what is a linked list. Okay, so as you can see that some kind of list is there as I have shown in the slide. So A is connected to B, B is connected to C, and C is basically finally saying null or none, right? So basically this structure is called linked list. Okay, so here each box here I will be calling each box as node. Okay, so I will be calling node. So basically you can say that there is one node, right, which is connected to another node, which is connected to another node, which is connected to another node, and so on. Okay, and so on, right? At the last node you can say it is not connected to anything, so you can say it is connected to null. Okay, we also represent null like this. Okay, so I hope little bit you got to know that what is linked list, but here in this lecture it will be more clear that what is linked list, why we need linked list, and Python already has a list kind of data structure, right? Then what is the difference between list and linked list, and what are the operations which are possible on linked list? So many other things we will be seeing in this particular lecture. So let's get started. Now, first thing first, that given this structure, what is the basic element of this structure? You can say the basic element here is node, right? Basic element here is node. So the first thing first means that we will be first seeing that how to create a node, and then we will be seeing next that how to link two nodes. So let's just see how to create a node, right? Now in Python, we already know that you can write a class like this. So you can define a class node like this. Okay, you can easily define a class node like this. So in this class node, you are having init function, and then self dot value equal to value, self dot next equal to none, right? So what does this mean? Let me just tell you that if you call this particular class, if you create an instance of this particular class using, let's suppose, admin equal to node a. So you might remember what is an object, what is a class, and these things. So basically you can create an object of this class node using this line, right? Using this line, this is very simple line. This is just creating the object. Okay, now just after this line, do you know what happens? The moment you write this line, then what will happen? There will be a node created, right? There will be a node created which will be having here how many values you have in this particular object. You have two values. One is value. Okay, so value here I'm passing as a. So you can pass any value. Currently I'm passing a. Now by default the second parameter is none, so basically this is none. Okay, this is none. Is this okay to everyone? The moment you write this line, you will automatically get this. Okay, and this is how you are creating a node. So this particular slide is telling you how to create a node. Very simple. Okay, create a node. Understood? Now suppose if I print the value, for example, suppose if I print the value of n1 dot value, then obviously a will get printed, and if I print n1 dot next, then none will get printed. Okay, so that's how this particular thing work. These things are, I hope, are okay to everyone. Now suppose given this class I write these three lines, which means I create three objects n1, n2, n3. Okay, which are having the value abc. Okay, the moment I do this, as you know, there will be three boxes created in the memory, right? So one box is a, another box is b, another box is c. So there will be three box will be created the moment you write these three lines. What else happen? nothing, right? I mean, this is the only story, that you write this code and you get this, right? Something like this. So we have three separate nodes as of now, but what do we want? We want to make a linked list. And if you remember, the linked list looks like this, right? Linked list look like this, which means A must be connected to the next node and B must be connected to next node and so on. So basically, I'm just halfway done, which means I just have my nodes, but I have to link them. Okay, I have to link A to B and I have to link B to C, and then C is by default none, so I don't have to do anything here, but I have to link them. This is the remaining story. So basically this is to do, right? I mean, till now I have created three nodes, but you can say I have to link them. So linking is remaining, right? Link them. Linking is also very easy in Python. What you need to do, you can just say that a dot next, right, or n1 dot next is basically n2. That's how you can do it. Okay, so basically we want to link them, and now to link them, what you can do, you can just write n1 dot next equal to n2. The moment you write this line, so there were like three, you can say three nodes that you already have, right, which are looking like this. So these are the three nodes that you already have. You already have these three nodes, and the moment you write n1 dot next equal to n2, you will be basically saying this link. Why? Let me just tell you. See, assume that every node has some address. Okay. For example, let's suppose this node has 100 address, this node has 200 address, this node has 300 address. Assume like this, right? Now this particular field should be basically having 200. Okay, I mean, this particular field should be basically having 200, which means I should be writing n2 is actually 200. Okay, n2 is directly 200, so I should be writing n1 dot n1 dot next means this value should be 200, which means the moment I write equal to 200 or equal to n2. Okay, so I don't know the exact value of n2, so n2 address I don't know. So basically the way we write it, n1 dot next equal to n2, it means that it is now containing the address of n2, which means it will now start pointing to n2. And similarly, if you write n2 dot next equal to n3, right, which means this is n2 dot next and n3 is basically 300, right? So this value will be 300, which means that this will start point to this, right? So so basically this line will connect A and B, and the moment you write n2 dot next equal to n3, this will connect B and C also. Okay, so I hope that is fine to everyone, that how we are linking the nodes. It's extremely easy. Okay, how we are linking it? First, you need to basically create the nodes. How? You can just call the class node A like this. This is the first node. Node B like this. This is the second node. Node C like this. This is the third node. Okay, that's how you can create three nodes, right? And now if we want to link them, so basically currently you have created just A, I mean one node which is n1, the value, first value is A. Okay, another node which is n2, the first value is B. Another node which is n3, the first value is C. Okay, now if you want to link them, what you can do, you can write n1 dot next, which means I'm talking about this field. Okay, and the moment I write equal to n2, which means this will be containing the address of n2, or in other words, this will start pointing to n2, right? Similarly, if I write n2 dot next, right, which means this I'm talking about, and the moment you write equal to n3, it means it will start pointing to n3. Okay, so that's how it works. So linking and creating the nodes is very easy. Okay, I hope you got to know. Okay, so congratulations, we have our first linked list ready, right? That's very easy to create one linked list here. Great. Now basically this is the complete code. Okay, I can see this is easy and complete code, easy and complete code on linked list, right? Now let's solve this question. This question is easy question only. So there is one typo, just a second. It is n4 n5 n6 here. Okay, so this is also easy question. Let's just try to solve this question. What this question is saying, they are saying that you create 6 nodes like this, right? So you can have 6 nodes, 1 which is initial value is 1, and there is no linking currently. I mean, you are just creating using the first set of lines, right? Then 3, then 4, then 5, and then 6. So by default everyone is having in the second field, everyone is having none. Okay, everyone is having none. Okay, by default, right? Now the next set of lines says that n1 dot next equal to n2, which means now you are asking it to point to n2. So this is n1, this is n2, this is n3, this is n4, this is n5, this is n6, right? So n1 dot next equal to n2. Now n2 dot next equal to n3, n3 dot next equal to n4, n4 dot next equal to n5, and n5 dot next equal to n6. And interestingly, they are saying n6 dot next equal to n3, which means they are saying this is pointing to n3. So basically, they are making some loop kind of thing here, which is fine, right? So if you have this code, you will be getting this linked list. I hope this is fine to everyone because this is easy enough to understand. Okay. So yes, this is the answer. Basically, 3 will start pointing 4, 4 to 5, 5 to 6, and 6 is pointing to 3. I mean, they have drawn it like this. I have drawn like 4, 5, 6 here, right? And then I was saying that 6 is pointing to 3. I mean, the structure is same. It is just the way of drawing. Okay. So the answer is easy. Got it? Now let's solve this question. In this question, they are saying, suppose they give you some structure. I mean, I think this is the previous structure only. And then they are saying, let's suppose T is pointing to 3 and H is pointing to 6. Now they are asking, what is these values? Okay, what are these values? T dot next dot data. So they are asking T dot next dot data. T dot next is this, right? Which means this, I mean, these two are same. Dot data means actually this is 4, right? So this will be 4. Okay, the output of this will be 4. What about h dot next dot data? H dot next is this. Dot next is actually h dot next is this basically, and I mean these two are actually same. Okay, so h dot next is this. Dot next is this. Dot data again 4, right? Again 4. So this is again 4. H dot next dot data. So which means they're talking about this. So which means this is 3, right? H dot next is this. Dot data. I mean dot data means this is the first field where you will say it is 3. T dot 3 times next, T dot 1 time next, 2 time next, and 3 time next. Dot data, it is 6, right? It is 6. So 4436 should be the answer. 4436, right? I mean, this is a complete code. If you want, you can basically create this structure and then check. Okay. So let me just do it. 4436 is answer, right? If you run this code, you will be getting 4436. Okay. So there is small typo. This is h is not n4, h is n6. So just you can do it n6 and then you can run this code, right? Easy enough. Okay. I hope you got to know that how to answer this question, which was easy question, and here you are getting 4436. Okay. Now let's just see that what is difference between Python list versus linked list. I mean, we already have list in Python. How does it look like? I mean, this is basically just a list in Python, right? 1, 2, 3, like that, right? You can have any number of elements. This is a list in Python, and linked list looks like this. So basically, 1 is pointing to 2, 2 is pointing to 3, like this, right? So linked list look like this. So what is the difference between these two? Basically, Python list is kind of array. Okay, it's kind of array. Array means contiguous location. Okay, so basically why I'm saying kind of, it is actually dynamic array. Dynamic means like you can even, I mean, it is not necessary to tell the size in front. Okay, I mean you can keep on adding. So that's why it is called dynamic array. So actually you don't need to know much about it. Only thing I'm saying, it is kind of array. Okay, so basically Python list keep all the elements side by side in the memory. Linked list keep a separate box. Okay. So Python list look like this. It is basically all together in the memory, and linked list basically is scattered. Okay. Linked list is scattered. Now when you talk about adding more elements, then the Python list, it grows automatically. I mean, it is basically dynamic array. Okay. Dynamic array, you can grow it. To grow it, basically what happens, like in the memory, let's suppose you are storing 1 2 3 4 5, and now there is no space after it, right? Let's suppose there is no space. Okay, Then if you want to add 6, then it has to be first copied to somewhere else, and then you can add 6, right? I mean, internally it happens, you don't need to know. So basically dynamic array means that if there is no space after it, then you can copy the whole array to somewhere else, and then you can add. Okay, that's called dynamic array. Anyway, Python implemented internally, we don't have to do it. Okay, so basically it automatically grows. I mean, you don't have to do anything. And here also, like, you can easily add, like here also it is very flexible, it is also very flexible. These are kind of similarity, but sometimes you need to shift to a larger block to copy everything. So basically internally it happens, right? This happens internally, right? uh Here you just need to create a new box and connect to the chain. No copying or moving is needed, right? But internally sometimes we have to copy all the things if there is no space after it, right? Because ultimately we have to keep all the things contiguously in the Python list. Okay, it is just like array. If you want to access any element, you can do the indexing here. Okay, I mean, indexing is possible here, right? Indexing is possible. But obviously indexing is not possible here. Okay, you just can't say that fifth element by just indexing, right? I mean, you have to traverse all the way. Okay, we will see this later on, but currently you can assume, I mean, you can little bit understand that you have to traverse all the way and to get that element. So basically here indexing is not possible, right? So you can say indexing not possible. Okay, so it is same as saying that what is the difference between array and linked list. Okay, I mean, same as saying what is the difference between array and linked list. So Python list is just array. So when you talk about Python list versus linked list, it is same as saying array versus linked list, right? So here data is kept side by side. Here the data is scattered, right? Here you can grow easily. Like, I mean, you have to copy all the elements. Internally it is done, but yes, you have to copy all the elements. But here you can do just by linking. Here you have to basically store two things, right? Just to store one, you have to store two things. So basically this is called pointer, right? I mean, there is extra pointer that you have to store. Okay, so basically, yes, we have to store extra memory for the links, right? Here the indexing is possible, here indexing is not possible. So it is best for reading and indexing. It is best for if you want to frequently insert in the between, okay, or delete. Okay, if you want to delete or something, then linked list is better. We will see this and you will be able to relate. It is just same as saying, okay, array versus linked list. Linked list, right? Okay, I hope you understood. So now let's just see that how to print a linked list. Suppose they ask you that given this linked list, can you print it? Okay, that's very easy, but still let's just see that how to print a linked list. Okay, so given this linked list, what do you think that what we need to do to print the linked list? Obviously, we have to go through each of the nodes, and then we need to print this linked list, right? So now let's just see that how to do it. So one thing is for sure that we will iterate. So first we will go to this node and then this node, right? That's what we need to do. But now we need to understand that how to jump or how to hop over the nodes. Okay. So that's very easy. Like, what you need to do, you just need to, let's suppose head is pointing to this node, right? So you just need to do one thing, which is like head equal to, I mean, if you want to go to this node, that's very easy, right? You can do head equal to, I mean, basically, ultimately, you want to shift this head, right, to here. So, which means head should be equal to head dot next. Okay. See, head equal to head dot next means that whatever head dot next is pointing to. So basically, whenever you do, like, we don't call it pointer, but because pointer is one very, logical or very, I mean, the mapping of pointer is very clear to everyone. So I'm using pointer word, but in Python we don't call it pointer. Okay, Python we call it references and all, but I will be still using the word pointer, because pointer is something which is like very directly connect to our mind. I mean, very easy to understand in terms of the English language. Okay, so that's the reason I will be using the word pointer. So what I'm saying here is that whenever you make two pointers equal, okay, in that case, what does this do? So let's suppose I'm saying p1 is pointing here and p2 is pointing here, and whenever we make p1 equal to p2 or something like this, then what does happen? because of this line. Basically this line just do one thing, very very nice thing. It does, it says that I will now p1 will get changed, right? So p1 will say that I will be pointing to whatever p2 is pointing to, which means after this line you will say that p1 is pointing to the same thing that p2 is pointing to. Okay, so basically this line is just saying that this head is pointing to now whatever head dot next is pointing to, right? Which means head dot next is actually this, right? Which is actually pointing to this, right? Which means like, I mean, these two are like same thing. Okay, so basically head dot next is this. So basically now head will be pointing to head dot next, whatever head dot next is pointing to, like that, right? Okay, so basically you will say that now after this line head will be pointing to head dot next, and that's what we wanted. We wanted to iterate over the node, so we wanted to go here and then we wanted to go here. So basically if we want to go here, the one thing is clear, we will do head equal to head dot next, right? And then head is basically this. Now if we want to go here, okay, if we want to go next, then I will be doing the same thing. Okay, because head will, it is just, this is a way of saying that we are incrementing head. See, whenever we do count plus plus, okay, in terms of arithmetic, doing incrementing count, basically like count plus plus, right? In terms of the pointer, whenever you are iterating over the, linked list or iterating over something, then in terms of the pointer, if you want to iterate or if you want to increase basically the pointer, then just like we increment the pointer like head equal to head dot next. Okay, this is one of the syntax. Now I just need to put that thing head equal to head dot next in a loop, because I need to keep on doing it. Okay, I will be first going here, then here and so on. Okay, so I will be putting in a loop, and loop will say head is not none. Basically I will be, whenever head is not none, I will be running, right? So I want to stop whenever head is actually none. Okay, head is none, at that point I will be stopping. So if head is not none, then I will be keep on running, right? So just imagine if you have if here, okay, if you have if here, then if head is not none, then what does this mean in terms of the English? Okay, let's not worry about the C language and all, or Python language and all. In terms of the English, what does this mean? If head is not none, then it is good, I mean it is true basically, right? So basically just replace this if with while, because I have to keep on doing it. So I will say that while head is not none, if like head is not none, then I will be keep on running. Okay, so that is why I have this kind of condition here. Okay, now in this condition I will be writing head equal to head dot next, which means I will be keep on doing, keep on incrementing, and the moment I do this, okay, or maybe before that. So basically I will increment, but at every node what I will do, I will also, since I need to print, so I will be also printing. So so it will look like this, like print head dot data. Okay, and then head equal to head dot next. Okay, I mean you print it and then increment it, print it, increment it. Very beautifully you can print for the whole linked list. Very simple code. Okay, very 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 simple code. So print and then increment, print and then increment. This is increment. Okay, this is like kind of incrementing pointer. Okay, okay, great. Now let's see this question. This question is easy question. If you have understood the previous thing, then this is a similar kind of question. They are saying that instead of printing, what you want to find out, you want to basically find out the total length of this linked list. Okay, find the length of this linked list. I don't want to print the linked list. I want to find the length. See, in both the cases, one thing is common. What is that? Here, if you need to find out the length, then you have to iterate, right? That's the only way. You have to iterate. Okay, so one thing is common, that I will be using a loop, and I will be basically keep on iterating. Okay, so iterate is very simple. To iterate, I will be doing head equal to head dot text. I mean, I will be iterating, right? But before iterating, I need to do what? I need to count. Okay, I need to count number of heads, number of basically nodes here. So initially I will say that count is 0, and then first I will do count plus plus. Okay, count plus plus, and then after that what will I do? I will just iterate, which means head equal to head dot next. Okay, so very very easy. So count plus plus head equal to head dot next, and ultimately after this you can just print whatever this function is returning, which means you can print the count. Okay, hope that's fine. So now let's just move to next question. So what this question is saying, we want to traverse a singly linked list. Singly linked list means like the linked list I'm talking, like we have been talking about. So we want to traverse. We want to traverse means iterate. So they want to traverse the singly linked list. We until we reach the last node. So basically, you should be keep on traversing. So they are saying until you reach the last node. So the difference here is that they are not saying that until you reach the none. Okay. So they have also specified that so that the after the loop ends, current points to the last node. So basically, what they are saying that after this loop ends, okay, यहाँ पे, okay, here. So at this moment, current should be pointing to last node. Okay. See, in earlier case, I had here instead of this blank, if you remember, in earlier case we used to have head is not none, right? Basically, it will be running until the point head is not none, which means the moment head is none. Okay, which means the moment head is here. At that point, it will get out of this loop, right? So which means after the loop, you will be having in this scenario after the loop you will be having head as none in this particular scenario. But the question is little different. In that question they are saying in this question they are saying that after the loop you want the current to point to the last node, not to the null. Okay, so basically how to solve this question? Here you can say that I basically want to end here, right? I basically want to end here. Okay, so wherever I want to end, I will be writing that condition, which means here how to identify this is this position. So basically you can say this is the position where head dot next is none, right? So you can say if head dot next is not none, then you will be keep on running, right? Head dot next equal to none. The moment it is none, okay, at the moment it is true, sorry, not right, not none. So basically the moment if it is not none, you will be keep on running. Okay, so the moment if it is not none, you will run. The moment it is none, okay, the moment it is none, you will say okay, let me get out of the loop, right? You will say let me get out of the loop. So basically here instead of head we are using current. So current dot next, okay, current dot next. So here the arrow actually I meant dot. Okay, so basically the current dot next is not none. Okay, at that moment you will get out of the loop, and if you do so, then now here current dot next will be actually none. Okay, so that's what you want, right? So you want to stop at the point where the current dot next is none. So basically if you want to stop at the end, then you will be writing, see, you will be writing just head. Okay, head is not none. See, let me just tell you the different scenarios. Okay, suppose this is the linked list that you have. Okay, so the scenario one is that if we want to stop at the end, okay, I mean I will be calling it the end. I mean if we want to stop at the none, okay, that after the end, like I want head to be none. Okay, so if we want to stop at none, this is like scenario one. Scenario two could be if we want to stop at the last node. Okay, if we want to stop at the last node. The third scenario could be if we want to stop at the second last node, and so on. I mean there could be any number of scenarios, but I just want to make sure that you understand everything. Okay, so if we want to stop at second last node, okay, this is the third scenario, and so on. So basically what we need to do in this while loop, I mean in the while loop, what we need to write, see, the condition is important, because in the body it is clear that what we need to write. See, I just want to check that what we need to write here. The condition here is important because in the body I will be just writing current equal to, I mean I just need to iterate, right? Current dot next. See, if we want to stop at the none, then what we will say? We will say that head is not none, right? So if you want to stop at none, then I will say that if head is not none, you keep on running, right? The moment head is none, I will be out. So whatever I want, I will write kind of negative of it. Okay, I want the head to be none, so I will be writing head is not none. Okay, some opposite condition here. Okay, whatever I want it outside the loop, right? Okay, not I don't want it here, which means that whatever I really want, I will be taking the opposite of it. Okay, to write it here. So what is the condition in the scenario one? Head is not none. What is the condition in the scenario two? What I want head dot next to be not none, right? Sorry, I want head dot next to be none, because I want to stop at the last node. So whatever I want, I will write opposite of it. I want head dot next to be none, right? Now here I will say not none. Okay. So whatever I want, I will write opposite of that. It is like bit counterintuitive. I understand, but hopefully it will be very easy as we move along. Okay. So just remember that whatever you want. So here you want in the third condition you want to stop at the second last node, right? If you want to stop at the second last node, it means what? Now you should answer me. So what do you want in terms of the language, in terms of the the Python programming, right? You want head to stop head here. So head dot next you want none, right? So head dot next you want none, so is not none, right? This is the third scenario. Okay, sorry, this handwriting is very not clear, but let me use the capital font so that it is little more clear. Okay, so is not none. Okay, next. Okay, so I hope you are getting the point, right? So whatever you want, you just write opposite of it. Okay, don't worry much. So here I want to stop here. So I want head dot next to be none. So I will write in head dot next is not none. Okay, so that the opposite of it actually comes whatever I want here, right? Okay, so now go to the next slide, which is saying operations on linked list. Okay, now we will be seeing what are the kind of operations possible. Operations in the sense like see, printing is also one operation. I mean, finding the length is also one operation. So operation like whatever you can do. Okay, uh, we will be seeing that what kind of operations possible. You can insert in the linked list, you can insert at the beginning, at the end, at the middle. So there are different scenarios which are possible, right? You can delete from the first, from the last, from the in the middle, you can delete something like this, right? So different possible scenarios. The thing is that they are not something very special, or they are not something they might be special, like the listed operations might be special, but they are not something new. Okay, but if we see these operations, then it will be just making us more familiar with the linked list. Otherwise conceptually the linked list is very simple. Okay, I mean, there is not much things, but you can consider these operations just like a practice. Okay, because not exactly as a practice. I mean, I don't mean to say that you should be knowing all of this. Okay, it's not a practice problem that you should be knowing, but it is just like that we are getting more familiar with the linked list. I mean, there won't be any special, so very primitive method will not come. We will be just using whatever we know. Okay, and so that we can make ourselves more perfect. That's what we will be doing now. Okay, so let's just start these operations. The first two are we have already seen, which are like finding the length and printing. It is like very easy. All are also the similar kind. Let's just see that how to insert at the beginning. So what we want that the input will be the pointer to the first node of the linked list, and we want to insert at the beginning to this linked list. So this is given to us that linked list is given. Then we want to insert some node, okay, at the beginning. So which means that we want this scenario. Now head should be pointing obviously here. Okay, so something like this we want. Understood? I mean, obviously earlier, let's suppose there must be some values. For example, let's suppose this is 1 2 3 4. Okay, we want to, let's suppose, insert 100. Okay, we want to insert, let's suppose, 100 here, something like this. Okay, this is basically one operation that we want to do. Now how do you think we can do it? So what is the first thing that is coming to your mind? See, the given is just a value. Okay, I mean, you first have to obviously create a node. Okay, just create a node, and then probably you need to manipulate some pointers, right? So step one could be the creating a node, right? Creating a node is very easy. Let's suppose you have the node class. So basically you can say this is just n1. Okay, n1 equal to, or you can name it other thing like n. You can just name it n equal to node of, you can just say here the value 100, right? This is same as creating a node. Very easy. Now what is the next step that you have to do? The next step is basically after creating a node, you need to set this next to whatever head is pointing to, right? I mean, the newly created node next should be whatever the head is pointing to. This should be the next step, right? Just think logically, okay, that what should be the next step, and then you will get to understand. So, okay, so you have this, right? Now the next step is that you will be doing head of sorry head equal to, okay, this was pointed by n, so this is actually currently pointed by n, so you will be doing n dot next equal to whatever head is pointing to, right? Sorry, so n dot next should be equal to whatever head is pointing to, which means that now this will start pointing to this. Now ultimately you need to shift the head also, okay? So here you will be saying head equal to whatever n is pointing to, okay? So this is really nice code. So here you will be saying head equal to whatever n is pointing to, right? So let's just see. So yeah, that's creation new node, they are calling it new node, which is okay. Okay, so basically they are directly returning new node. Yeah, that's also fine. I mean, this is even a better method. So basically, instead of manipulating head because we don't need it, okay. So we can say that now we will be returning n directly. Okay, we will be returning this n directly. So I hope you understood that what we are doing. Okay, so just think logically that what we need to do, and then automatically you will get to understand the things. Okay. So basically using this, we are actually inserting at the beginning. Now let's suppose for the sake of just understanding the method, let's suppose we do this question. Okay. And in this question we say that initially let's suppose head is none. And if we call this 10 inside the beginning, 10 inside the beginning, 20 inside the beginning, 30, something like this. If you call these functions, then which of the following linked list will be created after this code, okay, after the above code. So see, head is initially none. Now the moment you call with the 10, then what it will do? So 10 will be this node, right? Okay. So head will start pointing to. I mean, this is the first node that we have just created, right? Now when we are 20, you will be adding it basically when you call this line, you will be adding after head, okay? So basically, interestingly, this plus 20 will do what? Will basically say that 10 is as it is here, okay? 10 is as it is here, and 20 will be after head. Sorry. So this is 20 and this is head, okay? Understood? So basically what is happening here, that whenever you add 20, this is getting added in between, right? I mean, initially this is 10, let's just understand like this, okay? And head is pointing here, but after 20 it will be like this, and after 30 it will be like this, okay? So basically the linked list, the final linked list will be 30, 20 and 10, okay? So it will be the answer, B will be the answer, 30, 20 and 10. Understood? 30, 20 and 10. So B is the answer. Okay. I hope you understood this question. Now let's just move to the next thing, which is inserting at the end. So we have seen that how to insert at the first is very easy. Okay, that we just need to manipulate. I mean, create a node and just shift the pointer. Okay, very easy. Now let's just see how to insert at the end. It is little different from the previous problem in the sense that to insert at the end, whenever we talk about end or middle, basically apart from the first, so then at that point you have to traverse the whole linked list, okay? Because then only you will go to the end, right? So first you have to traverse. I mean, obviously you have to create, because it is insert. You can create a node, and then you have to traverse till this point, till the second last. Till the second last you need to traverse, and then basically you need to stop, okay? And then you need to say that its next is this, and then this is any winner, right? So the key point here is that you need to traverse till the last node, basically, okay? Till the last node, this node, this is the last node, right? You know this, right? How to do it. So basically let's just do it, creating a node. So okay, so here create a node, okay? Like I was thinking that I can show you the code directly, but let's just do it a little bit. So new node, okay, this is, let's suppose, new node equal to, this is node, and with whatever value you are creating, let's suppose this is 100, okay. Then you need to traverse till the end, okay, you need to traverse till the end. So to traverse till the end, you need to write while loop, which is head of next, head dot next, you want it to be none, so is not none, right, is not none, understood. And then you will just increment the pointer, head equal to head dot next, and at this point in time you just need to manipulate some pointer. So basically now the head is pointing here, you just need to say that head dot next should be the new node, head dot next should be the new node, which is n, n, and yeah, n is already pointing there, so yes, that's done, right, this is done. And anyways, like we have to basically return the head, so let's not use the word head here. We can first store the head in some pointer, let's suppose current equal to head, and then we can work on the current, so that ultimately we can return the current, okay. So hope you understood. So basically what we are doing, that we are creating a node, okay. I mean, this is just a corner case condition. If head is none, then what to do, okay, just a corner, this is not a step kind of thing, this is just a corner covering the corner case, right, okay. Then what we need to do, then we need to traverse till the end, right, we are storing in the current, then we will be traversing till the end, and at the end we need to manipulate the pointer, right, which is like basically earlier I can say that current is pointing here and n is pointing here. I mean, n is this node basically, right. Now what you need to do, you need to basically say current dot next equal to n, that's what you need to say, which is the new node, and then you can return the head, okay, because head is still pointing here, head is still pointing here, understood. So that's how you need to do it. By the way, even if you don't return the head, okay, I mean, you can return, that's fine, but even if you don't do it, then the effect is not changed, because head was earlier, I mean, before the function also it was pointing to this. Yes, using the head you have done something, right, I agree, I mean, you have inserted at the end using the head, but head is unchanged, okay. So whatever is the previous head, which means from wherever you are calling this function, in the from the main function you are calling, let's suppose, this function, something like this, I mean, so basically at that point in time, like, head is not changed wherever, from wherever you are calling this function, the head is not changed, so you don't need to return, okay, because the head is unchanged, okay. But if you want, you can return, okay, just to say, so for the simple explanation, I can say you can return, but even if you don't return, there won't be any difference, okay. The old head can be used anyway. That's not the point of discussion. The like the more important is to understand that whether you have understood the whole process, that what we are doing, right. First we are iterating, and then at the end we are manipulating the pointer, so that's all, right. Like iterating is just extra here, and which is like something which will be keep on coming if you have end, middle, or something like that. But I hope you are bit comfortable with the iterating, because we have seen length, finding the length, then we have to iterate, right, and we have seen that how to print the linked list, then we have to iterating, like we have already seen this. Now we are just using it, okay, as I told you that we will be just using the things which we have already seen, okay. Now probably let's just do this question. So this line will basically say that insert at the end, so initially we will be having 10, and at beginning doesn't matter, and because there was nothing previous, okay. Now this line will say insert at the end, right, 20. So at the end, if you insert, then you will be inserting like this. Earlier you were inserting here, right, at the beginning. Then if you add at the end, if you add, or if you insert at the end, then you will be inserting 30. So basically this time it will be 10, 20, 30, okay, because we are inserting at the end, okay, understood. Let's do this question. Assume the linked list currently is basically 10, 20, 30. After executing the following line, insert at the end, what will the new linked list? Okay, this is also easy. Like basically this is the situation. Then if you basically call this, then it will be inserting at the end. So which means 40 will be at the end, right? So answer is 10, 20, 30, 40. Okay. See, these are just small questions. I hope you're liking it. Just to make sure you're a little bit comfortable. Some of you might be thinking that why I'm, doing such small, silly questions. I can understand your pain, like because you are familiar. But just think about the people who are very, 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 beginners. So I hope you got this. This is easy question. So 10, 20, 30, 40, right? Now let's solve this question. What this is saying, consider the original and modified version of the insert at the end function. So this is basically, they are saying this was the original. If you remember, current dot next is not none. This was the original thing. But in the modified version, they are saying instead of current dot next, you just write current. Okay. What will happen if we use this modified version? That's what they are saying. This the question is for insert at the end. See, once we go to the end, right, then we manipulate the pointers or something like this. If we out of the while loop, see, if we do this, then out of the while loop, basically current dot next equal to new node will be there, right, out of the while loop, as it is written. Then at this point in time, can you tell me the value of current? It will be the opposite of this, right, opposite of this, which means current will be none actually, right? Current will be none. In that case, basically current has already passed the last node, right? Already reached to none, so current is none if you write like this. And then obviously this will not make sense. None dot next basically will give even the error. Okay, so this is called attribute error because you are using the dot operator. Dot operator is for the attribute. So basically this is saying that the code will throw an attribute error. Okay, so that's what will happen if you do so. Okay, so basically b is the correct answer. The thing here is that we have to be careful that where we want to stop, right? If you want to stop at last node, that at this point I will write in current dot next is not none, like this, right? This is the correct code. Okay, because this was the original code, this is the correct code. So let's now see this question. In this question, what they are saying is that you have a node which is like current, and current is pointing here at this 7. Now what they want, you want to insert a new node after current node, right? So you want to insert something here, right? This new node you want to insert something somewhere here. So basically it's very simple question, but since this kind of question we are doing first time, so that's why you can take a moment to solve this question. Otherwise it is simple question. So what ultimately we want something like this, right? So basically, let me remove this. So we have this. We want to insert a new node after the current. So let's suppose this is the new node, right? This is, let's suppose, our new node. And we want current dot next to point to here. But before that, see, before that, if we directly do current dot next, then we will be just losing this. Okay, we will be losing this chain, right? So that's why we have to be very careful first. Okay, the step one should be this. Step one should be this, which means we should ask new node next to point to whatever, okay, whatever this current dot next is pointing to. So which means new node dot next should point to whatever current dot next is pointing to, right? And then after that I will be modifying the current, right? So current dot next should be new node, right? Then after that I will be saying current dot next should be equal to new node. So that is how we can solve this question. Very easy, right? So we want new node dot next to point to this first. So which means, see, I don't want to modify the current first, because current dot next first, because I will be losing this link, and then this chain will be lost. So first I want new node dot next equal to current dot next, and then current dot next equal to new node. Yes, B is the correct answer, right? So B is the answer here. So let me write the answer on the next page only. So basically B is correct. Now let's just look at other options also. So what they are saying, new node dot next equal to none, doesn't make any like any sense. New node dot next should be actually equal to this. Current equal to new node. So the moment I modify this, it will be a problem, right? Current equal to new node means current start pointing here. Then obviously I will be losing this chain, and there won't be any use of doing anything after that, right? So new node dot next equal to current dot next. No, actually new node and current both are same, so it doesn't make any sense. These lines doesn't make any sense. So basically B is the correct answer here. Okay. Now let's see how to insert in middle. So what do I mean by that? That you will be having some chain. Okay, suppose let's suppose, let me take the similar chain. You will be having some chain, and I want to insert in the middle of this chain. For example, you are having this linked list. Chain means linked list, right? And then you want to insert at the middle of this linked list. So just, yeah, so I hope you are getting the point, right? Okay, so we want to insert at the middle. So that means that middle means that I mean not exactly half. So let's suppose they want to insert at after 15, so there will be some value given. Let's suppose given value I want to insert after this given value. Okay, I want to insert, for example, in this case I want to insert after this 15. I want to insert, and then that's how I want to work. Okay, suppose this is the case that I want to deal with. So what is the first thing that I will be doing? I will be going till the point. So this given value will be given to me. So I will be going till this point, right? I will be going to this till this given value, and then which means I will be iterating till this, right? And then I will do what? So I will be basically inserting very easily. So once I have pointer to this, then I can insert like the way I have inserted previously. So I will ask this to point here, and I will ask this to point here, right? That's how. But first step, you can say, to find out that where is this 15 or where is this given value. Okay, let's suppose given value is 15. New value could be anything. Okay, the 100, 200, it could be anything. But first I want where is this 15. So which means I will be running my while loop while, let's suppose, current is the pointer. So current is not none. Okay, current is not none. And sorry, or, so either current is not none, so I can say or current dot value. So I want the current dot value should be given value. So current dot value, I want it should be given value. If it is not equal to given value, then I will be in this loop. Okay, the moment it is given value, I will be outside this loop. And obviously I have to write current is not none, because if current is none, then I mean the dot value will be basically attribute error. I mean none dot value, it doesn't make any sense. So first thing that I have to write, let me just go to the next page, and then you will get to understand. So basically, I want this current to be not none, right? I mean, this is a basic condition. Obviously, then only this current dot value will make any sense. And ultimately, basically, this is the main condition, that I want current dot value to be not equal to given value. I mean, the moment it is given value, let's suppose this is 15. Okay, the given value is 15. I want to insert after it, right? The moment it is given value, okay, current dot value it is given value, then I will stop. Okay, as long as it is not given value, then I will be keep on iterating. So after this loop, so the moment I'm here, right, current will be pointing to 15, right? So basically, the moment I'm here, I can say current will be pointing to 15. So here the head might be pointing somewhere, but I can say the current. Okay, so don't worry about the head, but yeah, current will be pointing to 15, right? So after this while loop, current will be pointing here, right? Current is pointing here. See, this is just very small, or and but small and easy loop that you have to keep on iterating until and unless the current value is not equal to given value. I mean, the moment it is not equal to given value, you keep on doing it, right? The moment it is given value, you will be come out of the loop, and you will say that current is pointing here, right? And now you want to insert. So to insert, it's very easy. You need to create a new node, and you need to do new node dot next equal to current dot next. That's what we have just done, and then current dot next equal to new node, right? So I think, yeah, this is the input, and the task is to create a new node and place immediately after the given value. So basically, you can see here that new node dot next. So once you have this thing, so basically once you have this, then you can say new node dot next equal to current dot next, and current dot next equal to new node, right? So that's easy only. I hope you understood, right? So basically, this while loop and this is important. You can say these two are important only. This while loop is important, obviously, and then after that you have to do it. Otherwise, like, these are not kind of steps. These are kind of corner cases, like if current is none, which means the given value is even not found, then you will say given value not found, so, right, something like this. So basically these are not steps, these are like, I mean, important is this and this, right? These are just like to cover the corner things. Okay, so hope you understood. Now let's just solve the next question. So basically here is a question which is a simple question only. So there they are saying that current linked list is this: after execution of the following, if you insert, okay, at the middle, then how will the linked list look like? So basically, I mean, we have just seen that given value is 20 here. Okay, I mean, we need to insert after 20 basically, and new value is 25. So which means if you need to insert after 20, then B is the correct answer, right? 10, 20, 25, and then this is the correct answer. Okay. Let's see this. So here, if the list is this and you call this, what will happen? So basically you need to insert after 99, but 99 is not even present, right? So 99, if you check here, this is the given value. If this is not present, then I was printing. If you remember the code, obviously the code will be given in the question. Okay, these are just small toy questions that I'm having here. But if the given value is not there, then you will say the given value not found in the list. Given value not found, right? So that's easy question. So you will say C is the answer because 99 is basically not present in the list. Now let's see the next question. So initially they are saying head is none, and then they are saying you insert at the end. So basically either you insert at the end or beginning, initially doesn't matter. So 10 will be created. And then if you're inserting at the end, head is pointing here. And if you're inserting at the end, then 20 will be added here, right? So next to 10, 20 will be added. And then if you're inserting at the beginning, okay, now this is head 5, and if you're inserting at the beginning, then you can say that 5 will be here, right? So 5 will be created here, and head will be now pointing here. So it will be basically 5, 10, 20. And if you're inserting at the middle, after 10 you are inserting 15, right? So after 10 you can insert 15, which means 10, 15, 20 will be there. Okay, after 10 you can insert 15, and then at the end you can insert 25. So basically it will be 5, 10, 15, 20, 25. So A is the correct answer. Okay, so easy question only, just to know that, okay, how these functions are actually working, right? Obviously they can change the code, they can do anything. It is just these are just toy questions, just to make sure that you understand the basic working of these functions. Okay, similarly you can do this question. You are inserting at the end 1 and 2, and then after 2 you are inserting 3, right? And then at the end you are inserting 4. So 1, 2, 3, 4 will be the answer. Now let's just see how can I delete the first node of the linked list, right? It's very easy. So suppose you have any linked list, and if you want to delete the first node, what you need to do, you can just say that, let's suppose head is pointing here. You can just say that head equal to head dot next, right? And then head will be pointing here, right? I mean, you can just increment this head like this, head equal to head dot next. And then what about this? So basically nobody is pointing here. Okay, nobody will be pointing here. This link will be broken and nobody will be pointing to this. If nobody is pointing to some memory, then Python automatically free up this. Okay, you don't have to free up this. You can just say head equal to head dot next. Okay, so here if head is none, then obviously you don't have to do anything. If head is not none, you can directly say that return head equal to head dot next, or you can directly return head dot next, right? I mean, this is the new head. Okay, you don't have to do anything to the first node. So basically first node will not be pointed by anyone, and it automatically be treated as garbage. So this will be automatically delete. Okay, automatically Python will automatically delete it. Python will automatically delete it. You don't have to do anything. Basically if there is any memory, if that is not claimed by anyone or not pointed by anyone, then Python automatically delete it. That's called Python garbage collector. Okay, anyway, you don't have to worry about this. You can just say that, okay, head equal to head dot next, or maybe head dot next you can directly return, right? For example, if I want to delete this first, okay, then the remaining will be 20, 30 and 40. The remaining will be 20, 30 and 40. Understood? That's very easy. Now suppose you want to delete the last node of the linked list. Okay, suppose there is a linked list. Now you want to delete the last node. See, if you want to delete the last node here, the only thing that you have to be basically, very careful is that you have to stop at this point. You have to stop at the second last. Which means if you want to delete this, then you have to stop at this. Which means you have to stop at current dot next is not none, right? Is not none. If it is not none, then you can keep on moving. Basically, current dot next means this, dot next means this. If it is not none, then you keep on moving. So basically here, the only key point that you have to remember, or you have to basically be careful, that you have to stop at this point. You don't have to stop here. I mean, there is no benefit at stopping here, because if you stop at this point, then how can you delete this node? Because to delete this node, I have to stop previously. Okay, I have to stop one previously. The reason is obvious. What is the reason behind it? The reason is that basically, if I stop at this node, then there won't be any use. If I stop at this node, then I can say that, okay, this is null, right? I want to make this null. Okay, then it will automatically be deleted. Get my point? So that's why you have to stop one earlier. Okay, so basically you can say, let me go to the next page. So here you can see that we want to iterate till the point that current dot next is not none, which means basically that this is, if this is current, then current dot next, which means I actually want to stop at this node, right? If I want to stop at this node, then I will be saying something like this. Okay, and then current equal to current dot next. Understood? So that's the point. I hope you understood that how to do this iteration. So basically, I want to increment till the point. I want to keep on going and keep on incrementing the pointer till the point current dot next is not none, right? And once I reach there, then remaining code is very easy. Once I reach there, then I can say I want to delete the rest, right? So I can say just current dot next is current dot next equal to none. So I will just say that, okay, let me just free this up. I mean, it will automatically be deleted. Python garbage collector will automatically delete it. So I will just say current dot next equal to none. Okay, I will return head. See here in this case, even if I do not return head, then also it will work, because see, I have not modified anything to head. I mean, using the head, I have done something that I completely agree, right? But head is still pointing here, and head is after deletion also head is pointing here. So even if I do not return head, then also it will work. But that's fine. Like, you don't need to worry about it. Okay, I hope you understood my point also. I am saying that since using the head, I am doing something, that's fine. But since the head is not actually changed, right? I mean, before deletion head is pointing here, after deletion head is pointing here, then I think it's fine, right? Okay, so let's solve this question. This is easy question. They are saying delete last head, right? So delete last means 40 will be deleted. So 10, 20 and 30 will be the answer. B is the answer. Okay, so there is nothing in this question. This is a very toy question. So but I hope you understood. Let's see. This is a little nice question. What they are saying? Why does the while loop use, okay, current dot next is not none instead of current dot next is not none? So they are saying that we have something like this that we want to delete. Now they are saying that why do you think that current dot next is not none? Okay, we are stopping here. Basically, they are indirectly asking that why do you think we are stopping here? We are not stopping here, right? Because we want to stop, I mean, why we are using this, why not this? Because we want to stop one node earlier, second last node, to skip the head node, no, to prevent the deleting two nodes, no. It makes no difference. No, it makes a difference, and we want to stop one node earlier. So I mean, we want to stop at a second last node. So that's why A is the answer, right? A is the answer. This is little nice question. I mean, not very nice, but yeah, just to make sure that you are getting the point, I have made little questions, so that you understand everything very clearly. So why we want to use this? Okay, not this, because this means that second last node, I want to stop at second last node. This is basically last node. I don't want to stop at last node if I want to delete the last node. To delete the last node, I want to stop at the second last node, right? Let's see this question. What they're saying: if we call delete last head without writing head equal to, what happens? So basically they are saying that if we are not, okay, whatever it is returning, if we are not even storing that into the head, then what will happen? The head node is still deleted, the last node is still deleted, function throw error, list remains unchanged, the list becomes empty. So basically the last node is still deleted, right? I mean, there might be the corner case when there is only one node. In that case, probably I have to write it, right? But if there is more than one node, okay, assume more than one node are there, assume more than one node in a list are there, right? In that case, like you can say last node will still be deleted even if you do not catch it, okay? I mean, even if you ignore whatever it is returning. Why? Because head is anyway not changed. I mean, using the head you have done something that I completely agree, but head is currently pointing here, and after deletion also it will be pointing here. So even if you do not take it in somewhere, I mean, if you even if you do not catch it somewhere, okay, even if you don't write head equal to, then also it is fine. Now let's just see deleting the middle node, right? So deleting the middle node means like there will be some given value and I want to delete that particular node, okay, whatever is a given to me. So for example, the given value will be given to me and I want to delete that node. So if I want to delete something, okay, suppose this is a given value and if I want to delete it, then I will be stopping one earlier, right? I will be stopping one earlier. Let's suppose this is the given value, okay. Suppose this is 30 and I want to delete this, okay, want to delete. In that case I will say I will be stopping here. So this is basically, I will say it is current, so that I can delete it, right? I mean, the only way I can delete it to make this pointer point to the next of this. So first I have to stop here. So I will be saying that current dot, I think traverse till the given we have done it, but traverse I want to traverse till before the given. So current dot next dot value should not be given. So I will be writing in the while loop, I will be writing current dot next dot value should not be given value. If it is not given value, then I will be keep on iterating, right? Something like this I will be writing. So basically, let me just tell you, you want to stop at current dot next dot value is not equal to given value, right? I mean, this is the main condition, and obviously you have to write current dot next is not none, then only dot value will make sense, right? Otherwise, if this is none, then how the dot value will make sense, right? So basically you will be keep on incrementing the pointer, and the moment you find it, okay, then you will say current dot next equal to current dot next dot next, which means current, if the moment you are here, current dot next equal to current dot next, which means current will be pointing now here, okay, and nobody will be pointing to this, so it will be automatically be freed, right? I want, the moment I reach here, I want current dot next to point to current dot next, right? Okay. So these two are important. Yes, in between, like given value is not find, this kind of corner cases might be there. Okay, if given value is not find, then if the, which means current dot next itself is none, then okay, return head, or maybe you can print that given value not find, something like this, right? Okay, so given value not find, not found, right? Something like this, like that you can do. But yes, this is the main while loop that you have to basically keep on iterating till the whatever you want to delete, just before that, right? Just before that, okay. And then the moment you reach, okay, let's suppose you want to delete this, okay, then you will be basically keep on iterating till this point, and the moment you reach here, you will say current dot next equal to current dot next, okay. That's how you can do it. Easy question, sorry, easy concept. Now let's just solve some question based on this. So they are saying that head equal to delete value, right? And then they want to delete this 10, okay. So basically if you delete it, then 10, 20, 30, 40 will be the answer. So that's easy, B will be the answer. Now if you want to delete 50, then since 50 is not there, so that's why list will remain unchanged. I mean, nothing will get deleted, right? Okay. See, currently I'm not printing anything in the function. Like if you're printing also, then you can print. So B and C could be the answer if you're printing also, depending on the implementation, right? If you're printing also, then B and C will be the answer. Okay. If 20 is there, if these are multiple values, then it will delete the very first, okay. It will delete the very first, although it doesn't matter that whether it is deleting this or this, but yes, it will delete the very first, because the way I'm implementing, I will keep on iterating till I found current dot next dot value is 20, right? So I will be basically deleting this 20, although it doesn't matter, but still, okay. So 10, 20, 30 will be the answer, right? C is the correct answer. So these are the very easy operations, and I mean, not easy operations, I can say these are the operations on the linked list. And And using these operations, you must have got to understand that okay, linked list is easy. I mean, you just have to keep on manipulating the pointers, right? So whatever you want to delete, you need to go just before that, something like this, right? These are the small things that we need to take care in the linked list. Now let's just see more in the linked list. Okay,